Hi, everybody. Thanks for joining today. We're going to give it about 30 seconds for everyone to log on. Looks like we've got a full house today. I see about 160 attendees and counting, which is awesome. Apparently people want to know things about CarbonCure and we're afraid to ask. For those of you just joining, we'll be about another 20 seconds. We'll get started. Okay, well, I see the numbers are still ticking up. We are coming on to 200 attendees, which is awesome. So glad to see everybody here. Thanks for joining today. This webinar is everything you wanted to know about CarbonCure, but were afraid to ask. My name is Christy Gamble. I will be your host today and also sharing my opinion on the opportunity available for the concrete industry to be a solution in the embodied carbon movement. A little bit of background before we get started on the context behind this webinar. CarbonCure has been delivering a series of webinars that are delivering thought leadership around the topics of embodied carbon, quality concrete production. We're really working with industry leaders in design, building owners, concrete producers to share various stories about how to employ innovative methods and solutions to reduce embodied carbon. We really encourage you to join in on these various types of thought leadership pieces that we provide. One of the things that's been kind of interesting is that the common feedback we often get after these webinars is, okay, well, this is really great information, but what exactly is CarbonCure? Can you just tell us what it is? So that's why we're here today, is to just tell you what CarbonCure is. Answer your questions about the technology, its acceptance in the market, the challenges that are associated with it. Between myself and Shannon, we hopefully know most things there is to know about CarbonCure. And just want to mention as well that we know that there is a wide range of participants on this meeting, from engineers and concrete producers and owners and policymakers. So everyone is welcome. And we are gearing, for the most part, this information towards ready mix producers, masonry producers, precast producers. So if you're a concrete producer and you've been really thinking of certain questions to ask about CarbonCure, please feel free to ask them today. This is the forum for it. Okay, so with that, I'm going to get started. Now, a few housekeeping items first. You are muted, so this won't be a live Q&A session, but you can ask questions through the Q&A program that's in the go-to meeting. So if you look on your screen, you'll see questions. Please feel free to type questions throughout. What we are going to do is we will spend about the next 20 to 25 minutes just presenting some material to give a background on CarbonCure, and then we are going to address all those questions. I expect we probably will not be able to answer all of the questions due to time. We will be capping this at 45 minutes, but we will do our best to answer as many as we can, and we will follow up after this webinar with answers to specific questions as well as further resources. There's also a chat window on the lower right, so you can use that, especially if you're having any kind of technical difficulties or questions. But please put your questions into the Q&A. And also, if you would, please fill out our quick survey at the end of this. Very quick disclaimer. And a little bit of background about ourselves. So first of all, my name is Christy Gamble. I am the Senior Director of Sustainability with CarbonCure Technologies. I'm also a board member of the Carbon Leadership Forum. I like to think of my role as bridging the divide between this sustainability movement, the designers, the architects, the owners who are leading the movement to reduce embodied carbon, and then the concrete producers who are providing solutions. There are a lot of players that exist in the space between design and construction, and we really try to bridge that gap and facilitate that communication. So that's the world that I live in. I'll be happy to talk a little bit more about that. I'm also joined by my colleague, Shannon Seipel, who is the brains behind all of this. So Shannon is our technical services manager. She's been with CarbonCure for 2 years. And in her capacity as the TSS manager, she supports our customers with the implementation of CarbonCure in their plants. So this includes technology integration, both physical software as well as the mix optimization of mixes using CO2. I will also note that Shannon is joining us from Kansas City, Missouri, and is a very sad football fan. So with that, let's move on to the presentation. First of all, did you know that concrete is uniquely positioned to respond to one of the most rapidly growing trends in today's construction? What trend exactly is that? It's the trend of embodied carbon. So embodied carbon is the carbon footprint of buildings and infrastructure before the operations begin. So if you want to think about a building, it's the carbon footprint of a building before the lights are turned on for the first time. Historically, when people, whether we're talking about designers, builders, whomever, talked about reducing the carbon footprint of buildings, a lot of times they were talking about reducing operational carbon. So reducing the impact of lighting and cooling and heating, those kinds of systems. What's happened in the design world lately, in the past couple of years in particular, has been a greater focus on embodied carbon, which is the carbon footprint that comes from the building materials and the construction itself. It's been found that embodied carbon is expected to account for about 50% of the carbon footprint for the next of construction in the next 4 decades. And that has resulted in the design community collectively saying, wow, we really need to do something about this, because it's a big impact on the overall carbon footprint of our buildings. And there's been, relatively little innovation in this space to date. So because of that, there are a series of missions that are aligned across various kinds of organizations to eliminate embodied carbon from the built environment by the year 2050. This can come in different forms. We see, for example, Architecture 2030 is actually pushing to eliminate embodied carbon by the year 2040. We see other missions such as SEI, which stands for the Structural Engineers Institute. They have a program called SE 2050, which is aligned on the mission to zero by 2050. C40 Cities, one of the programs in there is to hit 50% reduction by the year 2030 for the carbon that is created from infrastructure projects. So all sorts of different kinds of movements are happening. And in some ways they have different names, different numbers, but everyone agrees that we must do what we can now to reduce embodied carbon. What does that mean for concrete? Well, concrete has the opportunity to provide a solution to this challenge. Carbocure is one of the solutions that can be used to ultimately support the industry's decarbonization. Carbocure is CO2 utilization in concrete. So Carbocure is an easy to adopt solution, a technology that injects CO2 into concrete during mixing. Once injected, the CO2 chemically converts into a mineral, which results in compressive strength gains. These compressive strength gains enable concrete producers to optimize mixes, which can realize cost savings as well as reduce further embodied carbon. Ultimately, the process reduces embodied carbon and creates opportunity for business growth with the design community. For the designers that are on the call, the concrete that's made with Carboncure's technology is delivered to construction sites meeting the same quality and other performance criteria, but with reduced embodied carbon. Same concrete, less carbon. Carbocure to date is operating at over 300 concrete plants globally. Most of these are within North America, so you can see the map here of the US where the majority of our production lies. We are expanding into other plants across the globe. So for example, in Singapore, we have wonderful producers that are operating there, and other parts are developing quite rapidly. To date, Carbocure is being used in over 8.5 million cubic yards of concrete. This has resulted in over 100,000 tons of CO2 saved. Now, our mission as an organization is to achieve 500 megatons of carbon emission reductions annually with the cement and concrete sector by the year 2030. So we have a little bit of a ways to go to get there, but we're really excited by the progress that we've made so far. I will note that this technology is compliant with ASTM C494 Type S. And it has been used on a wide range of projects. So I'm highlighting some of the, the fun projects, the high profile projects here. I should note that of the 8.5 million cubic yards of concrete, a lot of that concrete has been delivered to driveways in Indiana and lampposts in Illinois, for example. So it's a wide range from just your everyday concrete to these great kinds of construction projects that we're highlighting here, from 725 Ponce in Atlanta, one of the first higher rise buildings that used CarbonCure, and throughout LinkedIn campus in San Francisco, Infosys Innovation Hub in Indianapolis. One of the really fun ones is the East De-icing Apron, so a concrete tarmac paving that was used in the Calgary airport. I sat on that tarmac for a while, and it was really exciting for me to admire the beautiful concrete. Obviously, McDonald's is a project in Illinois. Department of Infrastructure, or Department of Transportation in Hawaii has approved the use of CarbonCure. We see an aquarium in Atlanta, and of course, one of our marquee projects is currently under construction right now, Amazon's headquarters in Arlington, Virginia. So with that, a little bit of background on CarbonCure. It's my pleasure to hand it off to Shannon, who is going to provide a more technical description of how the technology works. Shannon?
Great, thanks Christy, and thanks for that introduction. I am a sad little Chiefs fan today, but we'll get through it. So I am going to kind of walk us through the entire process of how the technology works. So we're going to start with the beginning, which is the CO2 supply. So the CO2 is collected from large industrial sources. So think fertilizer plants, ethanol plants. CarbonCure does not capture the CO2. This is done by industrial gas suppliers. So companies such as Praxair, Linde, Air Liquide. These companies collect CO2 from waste sources. They purify it and they turn around and sell it. It turns out actually that this purified waste CO2 is already a pretty large market. CO2 is most commonly used for carbonated beverages, cooling mechanisms, different things like that. I'll be honest, when I started at CarbonCure a couple years ago and heard that the CO2 in my Diet Coke came from a fertilizer plant, most likely, really thought about kicking the soda habit. But it's the same CO2 they use in the beer. So, we're gonna let it go and know that it's been fully purified before it gets to us. But it is important to note, though, from an environmental perspective, that CO2, while it is being collected and reused for other purposes, it eventually makes its way back to the atmosphere as a pollutant. So, for example, that Diet Coke, when you open that can and you hear the fizz, that's the CO2 going back into the atmosphere. But what we're doing with CO2, we're introducing it into concrete. It chemically converts to a mineral, which means it never goes back into the atmosphere because it no longer exists. So getting back to how it works, the CO2 supplier, they'll permanently install a tank at any concrete facility where our CarbonCure technology is installed. As you see here, the concrete tank is about 4 by 8 feet, and it's pressurized. So under pressure in that tank, the CO2 exists as a liquid. The CO2 supplier will come by the plant on a regular basis. Typically that's monthly, depending on your production volume, and that they will just refill that tank with liquid CO2, and that's what gets used into the concrete. So how the technology works. CarbonCure's technology delivers a precise dose of CO2 into the concrete mix, just like any other admixture. So our system is integrated with the batching software at your facility, at each individual plant, which means it's communicating with that software automatically to deliver the right dose of CO2 for each concrete load that's being batched. The CO2 itself is dosed by weight of cement. So the exact amount of CO2 will vary, with different mix designs that are used depending on how much cement you have in those mixes. But on average, what we're injecting is about 1 pound of CO2 per yard. So this metering and injection system, it's actually happening during the batching process. So at the exact same time as everything else is happening during that batching sequence. So there's no impact on cycle time. So therefore, there's no impact on your construction schedule. There's not a delay for using CO2. So from an operational standpoint, CarbonCure is delivering that dose of CO2 just like any other admixture would be at your batching facility. This is what the CO2 looks like as it's coming out of the discharge nozzle as it's being dispersed into the concrete. So it's almost like a dry ice or a snow. Now, carbonated concrete is created through what's called the reverse calcination reaction. So where calcination involves breaking that calcium carbonate mineral apart during the initial cement manufacturing process, where that CO2 gets released and becomes a greenhouse gas emission, what we're doing with reverse calcination is putting that calcium carbonate mineral back together. So when we're injecting CO2 into the concrete, that CO2, it's almost like a magnetic attraction to that calcium oxide in the cement. So those two molecules get back together in their natural state, which is a solid calcium carbonate or a limestone mineral. But where the real value comes in, and kind of the key to all this, is when these calcium carbonate molecules are created, when they're created chemically inside this concrete mix, they're very small. They're nano-sized particles that will bind to the outside of the cement grain, thereby increasing the surface area, and we're making the cement more efficient. So there's about 0.2% of the cement is going to react with that CO2 that we're injecting, and that's what forms the nanoparticles or the nanominerals, while the remaining 99.8% of the cement will continue to undergo normal hydration, but there'll be that enhanced efficiency thanks to the nanominerals. So more efficient cement means a higher strength. So what you're seeing here, if we were to do nothing else other than take CO2 and add it to your concrete mix, that precise dose, we typically see between 3 and 7% improvement to compressive strength at 28 days. You know, like all things concrete, there's definitely some variability, you know, with the results, but we've seen up to 10% improvement just by adding CO2. So what you see here in this slide, higher strength gives us the ability to adjust concrete mixes and reduce the cement content. And that's where the real value of the technology comes in, especially when you're talking about the relation to carbon savings and what we can do, which Christy will talk about here in a bit. But what we're looking at in this example here is a case study that we did, a normal concrete mix that would reach 4,000 PSI at 28 days. That's the black bar, the control mix. The bar next to it shows that same mix with 5% cement removed. And as you can imagine, you take out cement, you're going to see a bit of a drop in strength. But then that orange bar is that same mix with the reduced cement plus the CO2. And what we're able to do is get that mix performing as it was before we took out any cement just by adding CO2. So this is an example of an optimized mix where we're working with the QC team to identify how much cement can be removed from any particular mix while still maintaining the same mix performance and mix characteristics as they had before, which is what my team, the technical services and support team, you know, that's what we work with the QC teams on primarily during implementation. So other than the impact on strength, there is no measurable or noticeable impact on any fresh or hardened properties. So, you know, fresh properties, we're not impacting set time, air content, workability, anything like that. Concrete temperature is not being impacted. We get asked that question quite a bit because, you know, it's CO2, it's a cold, dry ice material that we're adding, but it's a very small amount. As I mentioned, it's about on average, a pound a yard. So it really does not have any impact in the temperature. And then same with hardened properties, a neutral impact on all of those as well. There has been some pretty extensive durability testing and validation that has gone on in the past several years. State DOTs are doing some testing right now, different concrete producer verifications, third-party consultants, and ultimately all of the testing has shown that the CO2 injection process has a neutral to a positive impact on concrete durability. So worst case scenario, we're very confident saying it's neutral. We have recently completed a new durability FAQ that we'll make sure we send out to everybody who's registered here at the end. We'll send out a video of this, and we'll include the durability FAQ. It has a lot of really great information in there, because there'll probably be a fair amount of questions that we won't be able to get to on that today. But I'm going to pass it back to Christy now. She's going to talk about different market development opportunities that there are with CarbonCure.
Perfect. Thanks, Shannon. I've been following the questions that have been coming in while you were speaking, and I'll address one of them right now because it leads into this. So CarbonCure, on average, reduces about 25 pounds of CO2 per cubic yard of concrete. This really depends on the concrete mix. It can vary quite a bit based off of the amount of mix optimization that has been achieved. The carbon savings comes from two elements, from both being able to mineralize CO2 that would otherwise be a waste emission, and also by being able to reduce the cement content. So cement is responsible for the majority of carbon emissions, of the carbon impact in concrete. So by reducing cement, we're also able to achieve further carbon savings. So to answer the question, the 100,000 tons of CO2 that has been saved to date, that is from a combination of mineralized CO2 and optimized mixes. So the market opportunity is growing rapidly, and this opportunity is stemming in many ways from this movement to reduce embodied carbon. What we're finding is that this desire to reduce carbon exists not just among the sustainable design leaders, but in almost every kind of construction project that exists, from the contractors and the building owners. You know, if you give most people the option of saying, if all else is equal and you don't need to impact the quality or budget of the project, do you want to reduce the carbon footprint of it? The answer to that is primarily yes. And so as a result of that, we're seeing quite a bit of demands. This is an example of specification language that is popping up very rapidly in a number of different kinds of projects. You saw the reference projects I showcased earlier. There are many, many more coming down the pipeline that we will be talking about. The biggest challenge that we do have in this space is along the lines of prescriptive specs. And so a very common question that we get is, or a common response is, well, I don't think this is going to work in my market. Is my market going to accept this? Because my market's very prescriptive. And what we mean by that is that a lot of specifications ask for a minimum cement content and or a maximum water cement ratio. These types of specs can inhibit the ability of a concrete producer to optimize a mix. In other kinds of applications, particularly in the government procurement applications, we need to have approval to use CO2 within the concrete mix. And so this is a challenge that my team and I are addressing, and we're addressing it, to be honest, with quite a bit of success. There is a movement beyond simply CarbonCure to move from prescriptive to performance-based concrete specifications. This movement is supported by the NRMCA, and in fact, it's being led by the NMCA. It's being led by structural engineers. The SE 2050 Challenge is all about best design practices and concrete specifications to enable sustainability and innovation. And ultimately, we work with our concrete partners to change the specification market within their regions, to not only enable the use of CarbonCure, but also to provide a competitive advantage for the producers that we work with. And when I say we have a fair bit of success, we have a fair bit of success. This is a quote from Justin Lazenby, our technical services manager over at Thomas Concrete. So back when he provided this quote, Thomas Concrete had done about 1 million cubic yards of concrete with CarbonCure, submitted this on countless commercial work where engineers are reviewing it, and had exactly 0 engineers not approve the use of CarbonCure. It's a pretty good stat. As you'll see the footnote at the bottom there, Thomas has since surpassed 3 million cubic yards of concrete. And I'll have to check with Justin whether or not we could still claim 0, but whatever it is, it's a pretty impressive number at the end of the day. So I think it's an easier challenge to address than many producers might think it is. I'm not saying that there isn't work to be done, but we've had success doing that work. And we're also working with departments of transportations, municipalities to approve the use of CarbonCure in CO2 mineralization, and just also to encourage general best practices in sustainable concrete specifications. To date, the Chicago Department of Transportation, Hawaii Department of Transportation, City of Honolulu have approved the use of CarbonCure and are actively using it in various projects. And there are a number of other government procurement organizations that are in development to do so as well. So just the last thing to note for our concrete producers who are on the call is that the process of introducing CarbonCure equipment into a concrete plant it's non-disruptive, it's simple, but there is some work that needs to be done on that, especially as we integrate with mixed designs and then introduce it to the market and address the specification challenges that can exist in any given market. And CarbonCure is here to support and lead that effort. So we have a customer success team called the Foundations of Customer Success that are addressing any possible challenge that exists along the way and really supporting our concrete producer partners' efforts to use CarbonCure on as many applications as possible. So with Shannon leading the TSS team, I lead the Market Development Services team. Between the two of us, we've pretty much seen all there is to it, and we're now going to start to welcome all of the questions. So thank you very much for participating so far, and just getting to the first question. So Shannon, a question for you with CO2 purity. Does it matter what kind of CO2 purity is used, and what impact would that have on compressive strength?
Yeah, great question, Christy. The CO2 that we use is food grade CO2, and we've done some testing with CO2 from a cement plant to see where that is. But right now everything that we're using is food grade CO2, and the impact on the compressive strength is the chemical reaction, and so it's more cement dependent and not CO2 dependent.
Shannon, continuing on that, when we inject the CO2, how do we know that CO2 has been mineralized?
Yes, that's a great question. So the CO2 mineralization process, it takes place pretty much right after that CO2 is injected into the concrete. And we know there's no impact on fresh property. We know it has mineralized based on the performance that we're seeing with the tests that we're doing at the plant.
I'm going to ask another question for you here, Shannon, that's summarizing a bunch of different questions that are coming in. So all on a similar topic. I have questions here saying, can you use CarbonCure with Portland limestone cement, fly ash, slag? Couple of other materials are addressed in here as well. So do you care to comment on that?
Yeah, I'll just kind of answer all of it and maybe throw some more in. So as mentioned, that chemical reaction takes place with the cement alone. So we can absolutely use CarbonCure with slag, fly ash, SCMs. There is no impact. The CO2 itself is dosed on only the amount of cement that's in the mix. And then when we, get further into implementation and we talk about reductions, we incorporate total cementitious into some of those calculations and those values. But we have tested CarbonCure with Portland limestone cements. So that's something that's undergoing right now. So, stay tuned as those are getting more and more prevalent into the marketplace. There hasn't been any adverse effect. We're just kind of doing our due diligence and going forward. And we have don't have any adverse effect with different admixture packages. So we've worked with all the big name admixtures that that you can think of, and are working with those at our producer partners every day.
Shannon, I'll give you a break and answer the next question. So the next question that I see here is, what impact does CarbonCure have on the water cement ratio, and how do you address that with the structural engineering community? So the answer to that is that, of course, if we are reducing the amount of cement, the water content tends to remain the same. The yield is maintained in the concrete volume because typically the amount of cement that's reduced is replaced with a certain amount of sand or fine aggregate material. So the result of that is you have less cement, same amount of water, and then the water cement ratio therefore tends to increase by about 0.02, of course, depending on the mix. And so in some cases that can be a potential barrier on certain kinds of specifications where a maximum water cement ratio is specified, if that 0.02 increase happens to go above the specified water cement ratio. So how we address that is by providing information and data to the structural engineers on the project to make an informed decision for what is the best approach for their application. We do know that generally speaking, a lot of water cement ratios that are specified with over design. Oftentimes a project can take a water cement ratio that's required for a certain type of exposure class and apply it to the concrete specifications across the board. You don't necessarily need that kind of water cement ratio in a foundation, for example. So we do provide information that's publicly available, that's supported by the National Ready Mix Concrete Association, Structural Engineers 2050, on how to review specifications and to look at where a maximum water cement ratio might be applicable and where it might not be, and where it can be adjusted and where it perhaps should be accommodated. And then we also encourage our concrete producers to provide the data to the project teams that show that, you know, the performance is maintained. We know that validation. And so this is the approach that we take when it's really being addressed very diligently. And we found that by going through that process, when we first engage with a structural engineer and provide that information up front, it's you know, there can be a little bit of an exchange of information, a little bit of work to be done up front, but then we now have set a precedent moving forward. So we've done that, for example, with Hawaii Department of Transportation, who adjusted the not only allowed the use of CO2, but adjusted the minimum cement contents and maximum water cement ratios in accordance to the data that was provided. And so that's available for them moving forward. Okay, so Shannon, going back to you, in a dry batch plant, what stage is the CO2 injected into the mix? So actually on that note, perhaps if you could just clarify the operations of a dry batch versus a wet batch plant and how the technology integrates.
Yeah, absolutely. So at a dry batch plant, there is a nozzle, a discharge nozzle that's put in right at the cement boot, basically, and the CO2 is discharged right into the mouth of the truck with all the other ingredients for the concrete. And then at a central mix plant or a wet batch, it is injected into the drum of the plant. And what happens is we typically want to have about 80% of the cement already, you know, having been loaded. That cement has reacted with the water, so the hydration process has started, and that's when we start to the injection process for CO2. So like we said, it goes in during your batching cycle. It can be sequenced accordingly to fit whatever batching software that's being used at the plant. And we can adjust that sequencing if needed so that it fits accordingly and does not add any additional time on to the batching.
Great, thanks. I'll take this next one. It says, besides Amazon, what other large businesses are requiring technologies like CarbonCure in future projects, and what kind of projects are those? So that's a really good question. Now, I can't necessarily go into specifics on some of the projects that are specifying CarbonCure or using CarbonCure where it has not been publicly named yet, but I will give some generalities of the opportunities where we're really seeing this happen. So first and foremost, as I think could be expected, big tech is one of the biggest opportunities that we see. So big tech industry, we have leaders like Amazon, Microsoft, LinkedIn, who are leading climate initiatives, not just in construction, but across the entire operation of their organization. And so that is resulting in these tech industries employing or starting the deployment of low embodied carbon practices. Now, some of these processes take time to get out there, but there's no doubt a movement within these organizations to use these best practices to reduce the embodied carbon of their construction projects. And these companies are building fulfillment centers, they're building data centers. It's a real sweet spot for concrete, because there's a lot of concrete that goes into these types of applications. In fact, Amazon, just as an example, is one of the largest builders in the world right now for square footage of space. So this is an example of an opportunity. And of course, the various types of businesses that support the tech industry. We're seeing more and more distribution center type of organizations. For example, some of these organizations are Compass Data Centers, MDH Partners, Sudler, who are all developers of retail, who are developers of these buildings that can serve these big tech markets. So that's definitely a sweet spot. Another one is, of course, higher education. As you would expect, a lot of universities have very ambitious low embodied carbon goals. We see a lot of it in manufacturing. So the kinds of industries that are generally combating negative press for carbon emissions due to the manufacturing that exists within the plants that they're building. Those exact industries are looking for solutions that can offset some of the carbon that is emitted in their operations. So these are some examples of the prime areas. We're also seeing in policy, cities, the municipalities are really leading the way. The C40 cities, if you're not familiar with it, I encourage you to check it out and see if your city is a part of this organization, which is a group of cities that are actively looking for solutions to reduce embodied carbon. What's really interesting is that a lot of these policymakers know that embodied carbon is an important topic. They know that government procures 39% of concrete. What they don't necessarily know is, well, now what do we actually do about it? What kind of solutions can we employ to meet our objectives? So if you're a concrete producer, now's a great time to go to your local municipalities and say, I have solutions to offer, and work with them to provide best practices on any kind of sustainable innovation. You know, it's a great opportunity to remove prescriptive specs that might have been acting as a barrier to your quality control team for a number of years already. Another question here. Concrete over time absorbs CO2 naturally. Does this process affect the total amount of CO2 that concrete can absorb over time? It's a neutral impact on the CO2 absorption. And of course, this is another example of, you know, a great property of concrete is the fact that it does sequester CO2 over time. Concrete acts as a carbon sink. This can happen over time, and it can also happen right away in the mixing drum. So, you know, let's take advantage of the fact that concrete is it has this opportunity to be a carbon sink. So Shannon, I'll send this one over to you. Any special considerations for delivery systems or for concrete producer in cold weather areas?
Nothing specifically related to CarbonCure. No, we have producers. You saw one of the projects that Christy showed was the Calgary airport, where it's nice and frigid. So we've used CarbonCure in all applications in all weather. Just you know, we always recommend that you follow ACI cold weather concreting, and and maintain your concrete temperatures as ACI recommends.
And another question over here, I'll summarize a couple of questions that have the same topic. What is CarbonCure's impact on corrosion and pH? That's for you, Shannon.
Sorry. Yes, so there is not an impact on the corrosion and pH with using CarbonCure. There's been a fair amount of testing done there. So the pore solution is equivalent to that of just conventionally regular concrete that's being produced. When we're introducing the CarbonCure in the mix at the time of batch, the mineralization process that we talked about happens right away. It's a quick reaction that takes place. So there is not an impact to hardened concrete.
I had a question to repeat the cement percent savings in the usage of CO2 and also the ASTM compliance number. So ASTM C494 type S, ASTM C494 type S. And then Shannon, just if you can recap on the cement savings percentage. Yeah,
so that varies. I mentioned a couple different percentages. So when we're talking about an improvement to compressive strength, I said we've seen up to a 10% improvement. And when we're talking about reduction of cement, it is going to vary on just your regular mix performance, plant variability, mix design, but on average, it's between 5 and 7% of a cement reduction, cementitious reduction that you're able to take on your mixes.
And Shannon, what do we notice about Carbocure during the finishing process? So examples are set time, bleed water, surface porosity, early age PSI.
There's a question we get, and we have identified some of the most challenging finishers in the industry and have given them trucks with CO2 and without CO2, and we have yet to find one that can identify which truck had the CO2 in it. So there is not a noticeable difference at all in any of the fresh properties.
Fantastic. Last question I'll throw over to you, Shannon, is what are the safety measures in place for concrete producers?
Yes, so we will provide, our team will do safety training, we'll do driver training, we'll also do safety training with the plant personnel on our system, as well as the CO2 supplier will also provide safety measures for the CO2 tank itself. So we will do all that.
Perfect. All right, well, I'm going to cut it off now at this point for questions, simply in the interest in time. I really want to thank everybody for submitting your questions. Please feel free to continue to submit questions. Shannon and I are happy to continue the conversation. I think the various Carbocure sales reps are even happier to continue conversations if anyone's interested. So by all means, please feel free to reach out to us. I'd also like to encourage anyone who's interested in learning more about the specification side of things. In particular, we have a webinar coming up on February 25th called Specifying Low Carbon Concrete Without Environmental Product Declarations. So this is a really interesting topic. How do you specify low carbon concrete if an EPD, so transparency document, is not available? The speakers on this are going to be my colleague Eric Dunford, along with Michael Cropper, structural engineer, Thornton Tomasetti, Jennifer Wolf, Sustainability Programs Manager at Sustainable Building Partners. So we encourage you to join on February 25th. Please continue to ask questions. Please fill out the survey. And thank you very much for joining us today.
Thank you.